Okay, so here's another place where the square root of pi comes up in a really surprising way.
Yeah.
You like to play this game that you call dice racing.
Yeah.
Right? So you take two six-sided dice, you roll them, and you write down the number.
Yeah.
And then whatever number you get, like, what is it, 40 times first?
42.
42 times first. So every time you roll it, you make a little mark.
Yeah.
And then whoever gets 42 marks first wins.
Yeah.
And who usually wins?
It's 7.
7. So usually you end up with a graph that sort of goes up, and 7 is the highest. And who's usually the next highest? Or what other numbers usually get a lot?
I think it's 6, and for some reason 3.
Really? 3 sometimes gets a lot.
Yeah, I don't know why.
Oh, that's pretty weird. Well, if you did this a whole bunch of times, maybe instead of 42 times, like 42 million times. Wow. You'd see 6 gets
like that.
A little less, and 8 gets the same amount as 6.
Yeah.
And then it falls off.
5 and 9.
Would get the same.
9 actually won once.
9 actually won once?
Yeah.
Whoa. Has 3 ever won?
No, it's gotten high though.
It's gotten kind of high one time. And then you would see 2 and 12 don't get very much at all.
Yeah.
Okay, so you would see a distribution that looks like this.
Yeah, it's kind of like a pinball machine.
It is kind of like, it's
like probability.
It is like probability. In fact, it's a lot like probability. And this is related to something called the binomial distribution. And but there's another thing called the normal distribution that looks a lot like this. Normal distribution. Okay. And this relates to a graph, y equals e to the minus x squared. Whoa.
Wow.
Wow, we haven't even talked about that, but that's e. Have you seen e before?
Well, maybe a bit.
Yeah, where do you know the number e from?
I think there's an equation that I think it's e to the pi plus I.
E to the pi times I.
E to the pi times I plus 1 equals 0.
Yeah, this is a very famous equation
Wow.
about the number e. And the same e comes into making a distribution called the normal distribution that looks a lot like the distribution from your dice racing game.
Yeah.
And you know what? If you look at this function here, e to the minus x squared, it makes this real steep graph that looks like this.
Yeah.
And the area under the graph, when you learn how to calculate area under curves rather than just for squares, the area is the square root of pi.
Ooh.
So you wouldn't think the square root of pi had anything to do with your dice racing game?
Yeah.
It actually kind of does.
Wow.
Yeah, wow. Isn't that pretty neat?
Yeah.
So this curve sort of relates to this curve that has the square root of pi in it. And the normal distribution comes up in a lot of different places. And so when you learn about statistics way later on,
Yeah.
you'll learn about this. But it's really important, and this was also studied by Gauss. Do you remember Gauss?
Yeah, here's the guy who solved the 1 to 100.
That's right. Gauss is really famous for solving that 1 plus 2 plus 3 all the way up to
Yeah.
100. And he did some other things too, by the way. Like he studied this normal distribution.
Cool.
Yeah, he did a lot of things. Okay, you ready for your challenge problem that Chris Long came up with?
Yeah.
All right, here we go.